Okay, finishing up on 9.6, this is the root test. So this is the final test to determine convergence or divergence. The root test is especially well suited to solve series involving nth power. So this kind of resembles the ratio test in some ways, including the way that we test for convergence and divergence. And this is good for when the entire rule of sequence can be written as a power of n. So let the summation of a sub n be a series. A sub n, the series will converge absolutely if the nth root of a sub n is less than 1, diverges if the nth root of a sub n is greater than 1 or positive infinity, and inconclusive, again, just like the ratio test, if the limit of the nth root of a sub n is equal to 1. Okay. So let's look at number 6 here. We have e to the 2n over n to the nth. The nth term test is first thing we always want to check. In this case, it's inconclusive. We see that the n to the nth is going to grow at a faster rate than e to the 2n. This will go to 0. So it may or may not be convergent. We're just going to have to use the root test. Here we see that the entire rule of sequence has a power of n. So we can rewrite that as n with n as the power, and raise it and take the nth root of that. The nth root and the nth power will cancel out. So now we can just focus on what's inside the radical. So limit as n approaches infinity for e squared over n. E squared is just a number. N will increase to infinity. So we know that the limit of this is equal to 0, and 0 is less than 1. So therefore, by the root test, the series will converge. Okay, next one here, we see that the entire series is raised to the nth power. So we could go through, let's see, if we try the nth term test, it may not be very conclusive. This will give us negative 3 halves. So approaching the 3 halves raised to the nth. So looks like it may be divergent, but we're going to have to investigate a little bit further. Okay, it's not easy to tell with the nth term test, divergent test. So we take the nth root and the absolute value of our expression here. The nth root and the n will just cancel out. If we find the limit as n approaches infinity of the absolute value of negative 3n over 2n plus 1 is 3 halves. 3 halves is greater than 1. And by our condition here, the root test says if the series will diverge if the limit of the nth root is greater than 1. Okay, so in this case, 3 halves is greater than 1. Our series will diverge by the root test. All right, let me skip to the 9th example here. This is we can actually see that the numerator is probably going to grow at a faster rate than the denominator. So nth term test could potentially tell us that this is divergent, but we see that we have powers of n, so we're going to go ahead and just use the root test just for practice. And I'm going to switch the n and 2 around, and so I'm going to make it n squared and have everything raised to the nth power, and then take the nth root of that, which will cancel out. We can just focus on what's inside. So n factorial does grow at a faster rate than n squared, so the limit as n approaches infinity of this expression will diverge to infinity. So therefore, our series will diverge by the root test. Finally here, 3n plus 4 over 2n raised to the nth power. We see that the entire expression, the entire rule of sequence is raised to the power of n. So we take the nth root, use the root test. The nth root and nth power will cancel each other out. Limit as n approaches infinity for 3n plus 4 over 2n is again going to be 3 halves, just like what we saw with number 7. And 3 halves is greater than 1, so therefore our series will diverge by the root test.